Good morning, children. This is class 11th physics, unit number 10, oscillations and wave. This is chapter 14, oscillations. This is the part third of the video, and in this video, in this class, we will complete the chapter. Okay. So we had done the energy expressions, that is kinetic energy, potential energy and total energy for a simple harmonic motion. Now we are going to start with some systems which shows simple harmonic motion, and firstly we are going to discuss with the system of spring, right children? So just a second, Mita. So here you are given a spring. Here you are given a spring which is considered to be massless, and it is lying on a frictionless horizontal table. And with this we have attached a body of mass m, and this spring is connected to the rigid support. Right children? Now in this diagram, what they have shown you? They have shown you the equilibrium position of the spring. So at equilibrium position, the total force, the resultant force, the equivalent force on the system is 0. Now children, when you stretch the object of mass m, so when you are stretching it, you have displaced it by a distance of x. So the restoring force will come into picture, which will try to bring the object back to the mean position. वो बोलेगा वापस चलो mean position पे, तो एक force will come into play. So that force we know it is given by F equals to minus kx, which will be directed towards the mean position of the object. Right? And suppose if you compress the system, then the object will come towards the left extreme position. And in this case also, the restoring force will say, hey, come back to the mean position. And that restoring force will be acting towards the mean position. And it is given by F equals to minus kx. Right? We know this. Now children, we know acceleration can be written as rate of change of velocity, right? And instead of velocity, I can put here velocity is what? Rate of change of displacement. So instead of v, can I put dx by dt? Instead of v, can I put, if x is the displacement, I can put dx by dt. So acceleration can be written as d square x upon dt square. यहाँ पे d का square है, d दो बार है और यहाँ पे dt दो बार है. So it is d square x upon dt square. This is your acceleration. So d square x upon dt square is the acceleration of the body. And according to Newton's second law, force equals to mass into acceleration. Force is mass into acceleration. So if with this acceleration, if I multiply mass, right, force is mass into acceleration. So this is mass into acceleration. Force कितना है? Minus kx equals to minus kx. ठीक है? अब देखो, अब इसमें आप क्या करोगे? You are going to make d square x by dt square as subject of formula. So m जो है बेटा वो नीचे चला जाएगा. That is minus k upon m into x. And k by m is nothing but it is omega square. So here you can see that acceleration, this is what acceleration is directly proportional to the displacement. Means this system is performing here acceleration is proportional to displacement and it is acting in direction opposite to it. Hence it is performing simple harmonic motion. Hence it is performing simple harmonic motion. और simple harmonic motion में आपको पता है omega equals to 2 pi by t, ये पता है ना बेटा हमें. So if हम इसमें t को सब्जेक्ट ऑफ फॉर्मूला बनाते हैं तो क्या हो जाएगा? t equals to 2 pi upon omega. ओमेगा की जगह क्या मैं k by m लिख सकती हूँ? ओमेगा की जगह I can put k by m, right? So t equals to 2 pi upon under root of k by m, under root of k by m, right beta? So t equals to 2 pi अंडर रूट ऑफ m अपॉन k, क्योंकि वे 1 अपॉन में है ना, तो m ऊपर चला जाएगा, k नीचे आ जाएगा. सो दिस इज द इक्वेशन फॉर टाइम पीरियड, दैट इज t इक्वल्स टू 2 पाई अंडर रूट m अपॉन k, वेयर m इज द मास of the object that is attached to the spring and k is the spring constant whose value is m omega square. Right beta? If time period is this, what will be frequency? Frequency 1 upon 2 हो जाएगा. Right beta? So if this is your time period, then your frequency will be 1 by t. Right? Your frequency is 1 by t. You can see over here, that is time period t is 2 pi under root m by k. एंड फ्रीक्वेंसी उसका रेसिप्रोकल 1 by 2 पाई, के ऊपर चला गया m नीचे आ गया, अंडर रूट k by m. राइट बेटा? सो दिस इज योर one system, that is oscillation due to spring, which is performing simple harmonic motion. Now we are going to see the second system that performs simple harmonic motion. Okay children, the second system is a simple pendulum. So simple pendulum में क्या होता है बेटा? Simple pendulum, it consists of a point mass. This is your point mass and it is suspended, it is hanged with an inelastic and weightless string. ये जो धागा है उसका weight बहुत कम है and it is not having elastic, मतलब वो ऐसे ऐसे ऊपर नीचे नहीं करेगा, right? So it is inelastic and it is weightless spring, right, which is fixed at the upper end, as you can see, right beta? So if you want to find out the time period for this, so let's see over here. So children, over here at the extreme position, suppose it is over here. So we know the downward force is mg, that is weight, and the force in the spring, the force in the thread is the tension, right? Now if we see the two components of mg, then this component is mg cos theta and this is mg sin theta. Now mg cos theta component and the tension force in the spring, they are opposite to each other, they will cancel out each other, and what is left? We are left with mg sin theta. This is the force which is responsible to bring the oscillations in the simple pendulum, and this is the force which is telling, oh, come back Bob to your mean position, right? So this is the restoring force. So your restoring force F is minus mg sin theta. Minus क्यों आया? Because this is directed towards the mean position, right children? Now if theta is very small, then we can take, see, sine 0. We know sine 0 is 0. So if theta is very, very small, then sine theta and theta, they become same. Right? So instead of sine theta, here we can put only theta. So F equals to minus mg theta. Here theta is the angular distance. Angular distance. So that angular distance from this triangle, we can say it is y upon L. So it is y by L. Theta is y by L. कैसे? कैसे? Theta equals to y by L कैसे हो गया? Because what you have to do is, children, you have to consider this triangle and then you will find out the value of tan theta, that is opposite by adjacent. And as theta is small, it will be, the tan can be neglected and your theta is y by L. Right? So let's put the angle, let's put the value of theta as y by L. So this is your y by L. Right? Now this y is what? Displacement. ये x क्या है? Displacement है. तो y को अलग कर लो, सॉरी y यहाँ पे x नहीं है, यहाँ पे हमने y बोला है, x भी बोल सकते थे, नो प्रॉब्लम. बाकी जो पैरामीटर्स हैं mg by L, उसको हमने k बोल दिया, दैट इज द constant value, mass of the bob constant, acceleration due to gravity g constant, length of the string constant, change नहीं कर रहे हैं, so all that constant we will call it at k. So this is the formula for restoring force. We know F equals to minus kx. Yes. So it means simple pendulum, it performs simple harmonic motion, and its time period can be given by, the time period for simple pendulum is given by t equals to 2 pi under root m by k. 2 pi under root m by k. Last only we did, है ना बेटा? t equals to 2 pi under root m by k. But अगर आप children इन दोनों equations को if you divide or this is force, this is force. If you compare them, minus mg by L y equal to minus k. Y cancel, minus minus cancel. If I take m, I am keeping over here, k को नीचे ले आती हूँ, L will go that side, G will over here. M upon k अगर मैं इस equation में से निकालती हूँ, M upon k is what? L by G. So this value of M upon k, I am putting it over here. So T equals to 2 pi under root L by G. This is the equation for time period of simple harmonic motion. So this is a time period of pendulum, right? So let's move to the next topic. So children, our next topic is undamped and damped oscillations. So damped oscillations, as you can see in the diagram, they are the oscillations whose amplitude is decreasing continuously with time. So when simple harmonic system whose amplitude continuously decreases with time, such oscillations are called damped oscillations. Right, beta? And those oscillations whose amplitude does not change with time, means its amplitude remains constant, right? They are said to be the undamped oscillations. Clear, beta? Okay. Now next is the free and the forced oscillations. Next topic is free and the forced oscillations. So children, free oscillations are the oscillation of the particle which is under the influence of restoring force, right? Means when a system of particle is oscillating, to be executing free oscillation means it is vibrating on its own with its natural frequency, right? For example, the tuning fork, when you struck it on the rubber pad, right, or the simple pendulum, right, when you are displacing it from the mean position, so what they are moving with their natural frequencies, right? So such oscillations are said to be natural, or they are said to be free oscillations. And in free oscillation, the amplitude, frequency and the energy of the oscillation remains constant. But when we are talking about forced oscillations, so children, forced oscillations, they are the oscillations in which an external force or external energy has to be gained from the surrounding to continue it, right? If you want the force oscillation to continue, for example, when a body is oscillating with the help of any external force with frequency different from its natural frequency, उसकी natural frequency से उसकी frequency different है, मतलब बाहर से कोई force है which is oscillating it, then such oscillations are called the force oscillations. For example, oscillation which are set up in the table when the stem of the vibrating tuning fork is gently pressed against the top of the table, or when a simple pendulum held in a hand is subjected to and fro motion. जब आप हाथ में पकड़ के simple pendulum का motion दिखोगे, that will be forced oscillation, and if it is doing by its own, it is your natural oscillation. Right, beta? Now this is the last topic of the chapter. Let's come to the last topic of the chapter, that is resonance. So children, resonance is a condition. It is a condition when the frequency of the external force is equal to the natural frequency of the oscillation. Then what happens? Then maximum transfer of energy takes place between the system and the surrounding, and the amplitude is also maximum. And this state of maximum amplitude is called the resonance. So in the state of resonance, the frequency of the external force and the natural frequency, they are same, right? Here they have given you the condition that both the frequencies, they are same. The natural frequency, they have shown it with V0, nu 0, and the external frequency, they have shown it with Vd, right? And when this condition is done, at that time the amplitude will be the maximum, right? Here they have given you an example. The example is that the soldiers go out of step. Soldiers do not march when they cross the bridge. Why? Because the frequency of the steps, if they match with the natural frequency of the bridge, then maximum amplitude will be produced in the bridge and the bridge may break, and therefore the soldiers do not march or they mismatch their steps when they cross the bridge, right? And it is because of the resonance only that the earthquake does not cause uniform damage to all the building in an affected area, even if they are built with the same strength and the material. Right, beta? So children, this is it. With the resonance, we are completed with the chapter. Okay, children, bye-bye. Take care.